Okay, and welcome to today's lesson, guys. We're looking at chapter 17a, which is all about finding the derivative from first principles. So what is the derivative? Well, the derivative is a way of finding the gradient of a curve. And if we're doing it from first principles, well, as you'll see, it's quite similar to the gradient equation, which is, of course, y2 minus y1 over x2 minus x1 for those who love their linear equations. So what we can see here in this diagram is if we've got the difference between 2 points, right? Where P is the original point and all of the various Q's there are different points along the curve, we can see that the gradient changes. And so this is what is known as an instantaneous rate of change, which is basically the gradient at a specific point, or the gradient between two specific points. And these blue lines, well, they're known as secants sometimes they're just known as tangents. But basically, by measuring the difference in the gradients as we go along the curve, we can eventually approximate a full derivative equation. Okay, and so the skill we're going to be working on today is simply just finding the difference between 2 points, or finding the gradient between 2 points, finding a tangent or secant line. Now, so say we had the point P, and that had an x coordinate, right? Which we just call x. And then, well, if you put that into the function f of x, you would get the value of whatever x was, right? But then we moved along h, just an amount of h, just an arbitrary amount. Well, you would then have the position of q, which is x plus h, and then you would put x plus h in, and you would get whatever the y value is by putting it in as f of x plus h. Right, so this is quite similar, as I said before, to if we were doing like year 9 maths, which would be, well, this is x1, and this is y1, and this is x2, and this is y2. And so, well, what ends up happening is it's the same equation. If you want to find the gradient between 2 points, normally m, right, is equal to y2 minus y1 over x2 minus x1. But in the case of finding the derivative, we don't call it m anymore, we call it f dashed x. This is how we refer to the gradient, or more specifically, the derivative of an equation. And so instead of it being y2 minus y1 over x2 minus x1, well, we get f of x plus h, that's our y2 value, right, because it's x plus a little bit, minus f of x, over, well, we would then have x plus h, that's our x2, minus x. And for those in the know, well, you can see that we've got x and negative x here, so they cancel out. And so this gives us our favorite formula for today, which is f of x plus h minus f of x over h. All right? And I should also mention that h is just a increment from x to the new point. And that is where limits come in, guys. So, well, what's a limit? Well, a limit is, of course, when we are sort of applying a concept of h getting as close to 0 as possible. So you see this a lot, lim h approaching 0, and that is, we can think about it like an asymptote, right? If we have a 1 over x graph like so, well, what you can see is that we are getting as close to 0, right, without ever reaching it. And that is because, well, you cannot have 1 divided by 0, yeah? And when we are trying to find a line between 2 points, well, you can't be 0, right? So the limit has to be approaching 0 without ever getting there. And so it's the same sort of concept. Anyway, let's jump into some questions, I reckon.
But before that, a quick message from our sponsor.
The decline in our school education continues. 90,000 Australian students are now failing to meet even the most basic literacy and numeracy standards.
Nearly half of all Year 10 students failing to meet benchmarks in maths, science and reading.
Across the country, numeracy results don't add up. Year 7s had their worst ever performance, almost 10% struggling with basic maths.
1 in 3 kids fail literacy NAPLAN test.
Nationally, the test results show some concerning trends in Australian classrooms. A significant number of students are not meeting the minimum standards for literacy and numeracy, nor are they catching up as they move from primary school to high school.
Okay, and so the first question we have here for question number 1 is, well, we've got this beautiful graph here of negative x squared plus 4x, and we've got the points P, 3, and then we've got our second point Q, which is 3 plus h. And then they've given us this weird bit here, which is if you were to put 3 plus h into the function, and you would get negative brackets 3 plus h squared, because that's our x squared, right? We're putting in 3 plus h for x, plus 4 bracket 3 plus h. And so, well, the first question, 1a, is to find the gradient between p and q. And how do we do that? Well, we use our favorite formula for today, which is f dashed x is going to be equal to f of x plus h minus f of x over h. Oh. All right, so let's go ahead and substitute that in. Remember, this is essentially y2 minus y1 over x2 minus x1. So our our y2 in this case is going to be, it's going to be negative bracket 3 plus h squared plus 4 bracket 3 plus h. And then that is going to be, now this is the tricky part, right? It's minus f of x, right? So f of x in this case is 3, so we're just going to be minusing 3. However, when we get into some more complicated questions, that's going to be something we need to note. And of course, all of that is over our favorite letter of the day, h. Okay, so then we go into our expansions. And if you've seen my Caffeinated Monday videos, you will see that we have a quadratic expansion, which of course is going to give us a squared plus 2ab plus b squared, right? And so in this case, our a term is 3 and our b term is h. And so we would get negative and then a bracket. 3 squared is 9 plus a 2 times ab, which in this case is going to be 6h. And then we're going to have plus h squared. All right. Then, well, the other side of things, we can then go ahead and use our favorite Harry Potter spell, expandio brackets, which is going to give us plus 4 times 3, which is 12, plus 4h. And of course, we are minusing 3 from all of that, and it's over h. Great. And so now we've got some more nonsense to deal with. Well, let's expand this one, negativize everything, if you will. So it's going to be negative 9 plus 6, not plus 6, minus 6h, minus h squared, plus 12, plus 4h minus 3 over h. Okay, well, next step, well, we have negative 9 plus 12. That's going to give us 3 minus the 3. This all cancels out. So the numbers, they are gonzo.
Bye-bye. See you later.
Then we have negative 6h minus h squared plus 4h. Well, the like terms there are the h's, not the h squared. And so we would end up getting, 6 plus 4, negative 6 plus 4 is going to give us negative 2h minus h squared over h. Just fix up that squared there. This pen's sometimes a bit annoying. And when we divide, well, we're dividing by h, so we're going to get negative 2 minus h. And then that is the answer for the first part of the question. The second part of the question says, find the gradient as h approaches 0, i.e. apply a limit, right? And so what we do is we go lim of h approaching 0, and that is going to be, well, it's going to be negative 2 minus 0, because we just basically substitute 0 in for h. And, well, very hard question. What is negative 2 minus 0? The final answer is going to be negative 2. So that is the end of the first question. Bang. Okay, and then moving on to our second question here, guys. Well, we've got the function of x squared minus 3x, and they give us the points of p, which is 4, 4, and our second point, which is going to be 4 plus h, brackets 4 plus h squared minus 3 bracket 4 plus h there, okay? And so, well, the first question is, find...
Hey kid, you want to buy some maths? I know a guy. His name's Tutoring. He does online lessons and he also does the Patreon, so you should check it out. Anyway, back to the video. Bye.
The secant, the gradient, and so, well, what we do is we apply our favorite formula of the day, which is f dashed x, I should say, is going to be f of x plus h minus f of x over h. Wow. And so let's go ahead and sub in now. So our f of x plus h is going to be 4 plus h in brackets all squared minus 3 bracket 4 plus h. And then we are, of course, minusing the 4. And that is going to be over our favorite letter of the day, which is H, not H. You goddamn Catholics. Anyway, it is H. Say it properly. Anyway, so we've got 4 plus H all squared, and that, of course, is going to be an A squared plus 2AB plus B squared, which is going to be, well, 4 squared is 16. Then we've got 2 times 4 times H, which is going to be 8H. And then we've got H squared with a plus or in there somewhere, timesing by expanding our brackets here with our favorite Harry Potter spell, expandio brackets. And so what we're going to get is we're going to get negative 3 times 4, which is going to be negative 12. And then we've also got negative 3 times h, which is negative 3h. And then that is going to be minusing our 4, all of that over h. Cool. So then we've got 16 minus 12 minus 4. Well, obviously, negative 12 minus 4 is negative 16. So these guys all cancel out. Kablamo. Okay, and then we have 8h minus 3h, which is going to be 5h plus h squared over h. Dividing by h, we then get 5 plus h. And that is the answer for the first part there. Moving on to question 2b or not 2b. All right. Okay. Bit of the old 2b or not 2b. Okay. What we have, the second part is to find the gradient if you apply a limit of h approaching 0. So, well, lim h approaching 0 of 5 plus h, what we're going to get if you, you substitute 0 in for h, don't you? So you get 5 plus 0, which gives you 5. How about that? And that's the end of that question. Okay, so question 3, they're asking for the gradient between 2 points, which we'll get into in a second, but the function that they give us is y is equal to x squared minus 2x, and they want us to find the derivative. So this is where we're starting to move away from the numbered points like 0.44 or 0.33, and we're going into actually manipulating the function a bit more. So in this case, well, the first point, p, we're going to have x, and if we put x into the function of y equals x squared minus 2x, we would get x squared minus 2x. And then, well, if you put q, right, and remember we're substituting in x plus h now, well, our x value is going to be x plus h, and then our y value, well, it would be